Hello students, the topic of this video is trigonometry. So, all of you know Pythagoras theorem. So, what does the Pythagoras theorem state? For a right angle triangle, the square of hypotenuse is equal to square of perpendicular plus square of base. Now, here in the triangle ABC, if you substitute hypotenuse, perpendicular and base with the small a, small b and small c, how does the Pythagoras theorem look like? It looks like this, that is b square is equal to a square plus c square. For angle A, B is the hypotenuse, A is the perpendicular, C is the base. So it looks like this. Now let's do something. Let's divide this equation with b square. So we have b square by b square is equal to a square by b square plus c square by b square. What do we have here? We have 1 is equal to a by b whole square plus c by b whole square. Now recall from your previous slides, what is a by b? A by b is sine square a. What is c by b? C by b is cos square a. So we have sine square a plus cos square a is equal to 1. So this is our first identity. Or sine square is equal to 1 minus cos square a, and cos square a is equal to 1 minus sine square a. What did we have? We had sine square a plus cos square a is equal to 1. Now let's divide this whole equation by cos square a. So what will we have? Sine square a by cos square a plus cos square a by cos square a is equal to 1 by cos square a. What is sine by cos? Sine by cos is tan. So this is tan square a plus 1. What is 1 by cos? Is sec square a. So this gives us a second identity, which is sec square a minus tan square a is equal to 1. Now let's use the same sine square a plus cos square a is equal to 1. Now let's divide this whole equation by sine square a. So sine square a by sine square a plus cos square a by sine square a is equal to 1 by sine square a. So the first term is 1. What is cos by sine? It is cot. And what is 1 by sine? It is cosec. So this gives us our third identity, which is cosec square a minus cot square a is equal to 1. So we have our three identities here, and these are called square relations, and these are also quite important from the examination point of view because you will be using them to solve your problems and identities. These are some of the key points that you have to remember while solving the trigonometric identities. First, remember the trigonometric and algebraic relationships. What are the trigonometric relationships? We saw quotient relations, we saw reciprocal relations, and we saw the identities. And the algebraic relationships like a plus b whole square, a minus b whole square, a square minus b square. So these are quite important while solving the relations. Now, you should understand this, that you can either start from LHS or RHS and apply the trigonometric and algebraic relations to reach on the either side. And the third one is better to start from a more complicated side. Why is it important? The more complicated side will give you the benefit to solve or bring each of this term to its simplest form. For example, if you have tan, you can simplify it to sine by cos. But sometimes you will see that both the sides are complicated. So in that case, you can either take LHS or RHS, or you can work out both of the sides together to bring to a common result and prove that LHS is equal to RHS. Using these key points, you can start solving your trigonometric identities and your problems. Thank you for paying attention. See you in the next video.